This video is going to talk about the kinetic molecular theory, specifically how we apply this to gases. When we apply the kinetic molecular theory to gases, we have to make 5 assumptions. The first is that gases have large numbers of tiny particles spread very far apart. Basically, that they have almost no volume, which gives them a very low density. This is true of a gas if it's at a high temperature or a low pressure, but isn't always true. These 5 assumptions allow us to talk about the ideal or perfect gas. The second assumption is that there are no forces of attraction or repulsion between gas particles. There are actually some of these intermolecular forces, but they're so small that it's okay for us to ignore them. The third assumption is that particles are in constant, rapid, and random motion. If you remember the video of gas particles you watched 2 pages ago, those particles did move very fast and very chaotically. The fourth assumption is that particle collisions are elastic, which means they don't cause the particles to slow down because no energy is lost. This is true of the collisions between particles and between the particles and the container. The last assumption is that the average kinetic energy of the particles, which determines how fast they're moving, depends on the temperature of the gas. If we were to heat up a gas, the particles move faster. If we cool the gas down, the particles move more slowly. In fact, if we cool the gas enough, the particles move slowly enough to become attracted to each other again and become a liquid. When we're talking about the behavior of a gas, there are 4 factors we need to consider. First, we need to think about the pressure on the container. Second, we need to think about the volume of the container. Remember that gases expand limitlessly, so the size of the container they're expanding to fill makes a difference. The third factor is the amount of gas particles actually in the container. And the fourth is the temperature of the gas. When we're talking about temperature of a gas, we want to talk about it in Kelvin because there are no negative temperatures in Kelvin. We can talk about these factors using the kinetic molecular theory and gas laws.